we'll go over the nomenclature of these compounds we have here. And so to be able to answer, we first need to identify the functional groups present. And the functional groups which are present here, we just have the OH functional group. So, and they are both at the end. It doesn't matter which direction we take to count. So this will be position number 1 of the carbon, position number 2 of the carbon. We don't have any other carbon, we only have 2 carbons here. Therefore, to name this, we'll simply state the position of the carbons. So this is going to be 1, 2, and then the name of this compound, only 2 carbons, that is going to be called ethane. But because it's an alcohol, it will be called ethane. We'll put di or. Notice that there is an E here because we have got more than one alcohol functional groups. So that is one thing that we need to get to realize there. Okay. Now let's get to look at, of course, if we didn't want to write it in this way, we could have also said ethane. I'll just write ethane like that. Notice the E here because we're talking about more than one functional group for an alcohol. And then I'll state the position out, position number 1 and position number 2. We've got alcohol, so that will be di and then O. What of the other one? We can see we have got an OH there and OH, so we've got 2 alcohol functional groups. This will be position number 1, position number 2, and then going around like that. Or I could have started here and then number 2 would have been this one and then going around. The group should always be given lower numbers. Now, these lines mean this alcohol is pointing in the board and this alcohol is pointing towards us. Now, because of that, we have got some isomerism at this point, that is, one is coming towards us and one is going away from us. So that this is a trans isomer. If they are both coming to our direction, that would have been called cis isomer. Therefore, this is going to be trans just by looking at those bonds. And then we state now the positions at which our alcohols are: trans 1, 2, and then this one is a cyclo. It has got 5 carbons, pentan, and then we state the position. We've already stated the position. How many alcohols do we have? We have got 2, so that would be di-O. So that is going to be the name for this compound. What are the next question? How many functional groups do we have? Well, we only have a triple bond there. And for this one, how do we get to name it? Since we have got a triple bond that is present, the triple bond is going to be the name of the whole of this compound because it carries more priority than alkane. An alkene carries more priority than an alkane. So this is going to be position number 1 and then position number 2. So this will be the parent name. But even as we get to name this parent name, we need also to identify that we have got a cyclo compound here. Okay, so we first have this compound here has got how many carbons? It has got 2 carbons. So that is supposed to be called ethene. But if we can look at this thing carries a lot of carbon than this one. So this is going to be named as a group and then this as a main chain. But remember, even if this is named as a group, still the name is going to carry the name of a what? A triple bond. Okay, this was supposed to be called ethene, ethene, like that, when you've got 2 double bonds. But because this is a group, we'll not put this E at the end. We're going to remove it and put YL. It is an alkyl group, so that will be NYL. So that will be ethionyl, and then we'll state the name of the other compound here, which is cyclohexene. So that is going to be the name of this compound. Now let's look at this one. How do we get to name it? Well, we've got double bonds. We've got triple bonds in this compound. So to be able to name it, you simply state the positions of the triple bonds, giving them lower numbers. So position number 1, number 2, number 3, number 4, number 5, and number 6 there. So the whole compound has got 6 carbons, so this is going to be called X. Now at position number 1 we have got a triple bond, and then at position number, okay, even another position here. Which position is that? Position number 1 we've got a triple bond. At position number 3 also have a triple bond, and then we simply say die because there are two triple bonds. Triple bonds are alkenes, so we're going to add Y and E at the end, diene. So that is going to be the name for this compound. Now let's get to look at this one. What will be the name of the first compound that we have? First, we need to identify the functional groups. We've got a triple bond, we've got also a double bond. Perhaps we can't name it well the way it is. We can also write it as a skeletal structure. We've got a carbon 1, number 2, number 3, number 4. On the fifth carbon, we have got this which are attached, CH3, the two of them. Okay, so 1, 2, 3, 4, 5 carbons. So we can write it as 1, 2, 3, 4, 5 carbons. And at the fifth position, we have got 2 methyls like that. Okay. And then at just the first carbon, we have got a triple bond. And then 1, 2, 3, 4. At position number 4, we also have got a double bond. 1, 2, 3, 4. So at this point, we have got a double bond. Now, how do we get to name this? The first thing is we need to understand the longest chain. Now, when you are telling which one has got higher priority, an alkene has got higher priority than an alkene. But when you are counting, when these two are together in the same chain, you are going to look at the two and ask yourself, if I get to count them from one end, which one am I going to get a lower number for? So if I start in this direction, the triple bond is receiving a lower number. If I start in this direction as position number 1, number 2, we see that the double bond is receiving a 2. So for this one, we are going to start in this direction as position number 1. But if even this one was at position number 1 there, so higher priority goes to the double bond. This would have been position number 1, and then it would have gone in that direction. So therefore I've got position number 1, number 2, number 3, number 4, number 5. Doesn't matter which direction we go. Let me say number 6 there. So that means at number 5 we have got a group there. Okay. So how do we get to name that one? So at position number 5 we've got a group that is going to be called 5-methyl. And then this compound has got 6 carbons, so that is going to be called X. Well, it is X now. At position number 4 we have got a double bond. You first always name the double bond before you can name the triple bond. So double bond, and then I'll put ENE, but I'll remove the E at the end because that's not the parent name. Put another dash. At position number 1 we have got a triple bond, and then put now the name of the triple bond, that is YNE at the end. So that is going to be the name 5-methyl X 4N 1 ion. And then for question B, what are the functional groups which are present? We have got an alcohol and a double bond. Obviously an alcohol receives much priority, so it will be carbon number 1, number 2, number 3, and number 4. So this substance we have here has got 4 carbons, so that is going to be but. It was supposed to be butane, but because there is a double bond, and by the way, this is an aldehyde functional group. I don't know what I mentioned earlier, that should have been alcohol. That's an aldehyde functional group. Okay, because we have got a C double bonded with O at the end of the chain. So that will be but. I'll start the portion of the double bond at position number 2, and then put ENE. But because this is not an alkene, an aldehyde carries more priority, so this is an aldehyde. I'll remove the E at the end and then simply put AL. So this is but 2A now. So that is going to be the name of this compound. I'm not even giving the position of this, because we know that for an aldehyde the functional group is always supposed to be at the end of the chain, otherwise it is a ketone. Now we have got another compound here. What are the functional groups? We have got a triple bond and a double bond. We start in the direction that gives lower number either to the double bond or a triple bond. So this will be position number 1, number 2, number 3, number 4, and number 5. So therefore this is going to be pent. Now at which position do we have a double bond? Position number 3. So that is pent 3 N, but I remove the E at the end because it's not the main chain or the parent chain. I put a dash, and then at position number 1 we have got an alkyne, so that would be ion. So that is going to be the name for that one. Or let's proceed and look at D. How do we get to name D? Functional groups which are present. We have got a ketone functional group here and also an aldehyde functional group. Now which one carries more priority between a ketone functional group and an aldehyde? An aldehyde carries functional group that more priority than a ketone. Therefore, we're going to give an aldehyde the first locant, the first lower number. This will be position number 1, position number 2, position number 3, number 4, and also number 5. Therefore, the name of this, at position number 3, we've got a group that is going to be called 3. Position number 3, we've got a ketone, but when a ketone is acting as a group, that will be oxo. So that is 3-oxo, and then the whole of this chain has got 5 carbons. That is going to be pentan, but because this is an aldehyde, to be called pentan now. So that is going to be the name for that one. Let's get to look at this also. What are the function groups which are present here? We have got a ketone there and also an alcohol. To which one carries more priority? Is it a ketone or an alcohol? What can we say? Okay, so in this case, if we can look at this one so closely, we have got a double bond at this point, and then we have got the OH. So priority is going to be given to, let me just try to look at that again. Okay, priority is going to be given to the ketone. Okay, so that is the one which receives much priority than the alcohol. Therefore, naming, we're going to start in this direction: 1, 2, 3, and then 4. So how do we get to name it? At position number 4, we have got an alcohol, and an alcohol has a group that is hydroxy. So that will be 4-hydroxy, and then this has got 4 carbons. That will be butane. Okay, at position number 2, we have got another functional group which is a ketone. So 2 and then a ketone, it ends in 1. So that is going to be the name. Or we could have said 4-hydroxy 2-butanone. So that would have been also the name. Now what of the next one? What are the functional groups which are present? So we have got a ketone there and also a ketone at that point. Okay, and just one thing which I left out on this one, so we're supposed to have an OH there. Okay, so we don't have 2 ketones, but this group which is here is no longer a ketone but a carboxylic acid, and this one is the one which is a ketone, and we know a carboxylic acid carries more priorities. Therefore this will be position number 1, number 2, number 3, number 4, and number 5. And the first thing we're going to name is this substituent group here, a methyl. At position number 2, I've got a methyl. That will be 2-methyl. I wanted to name the methyl first because this group, which is a ketone, as a group, it is called oxo, and O comes later in the alphabetical order than M. And then at position 4, we have got the oxo. Okay, and then we write now this is a This one has got 5 carbons. That is going to be pentanoic acid. So that is going to be the name.